So this tells me they want me to find the probability of A or B. So then, since I see there is an intersection, I need to put in the probability of A or the probability of B. Adding those both together, I have to subtract off what's in common between the two. So looking at probability of A, they tell me it's 0.6. Probability of B, well, that's going to be 1 minus, right? So probability of B is 1 minus the probability of B complement. And so that's going to be 1 minus 0.5, which is 0.5. So that's what this is, 0.5. And then I'm going to subtract this off. And so all of this gives me 0.9. So looking here, they tell us there's only 3 things happening, A, B, or C. And they give me the probability of A or B. And by looking at the 3 outcomes, you can see that there's nothing in common. So probability of A or the probability of B is just going to be adding these 2 together to get that. So the probability of C is going to be 1 minus everything else. So that's going to give me 0.3. Probability of A or C, I'm just going to add those 2 together. So probability of A is 0.4 and add on this 0.3, and that gives me a 0.7. So probability of A complement is going to be 1 minus the probability of A. So that's 1 minus the 0.4. And so that gives me 0.6. So these 2, I would want you to use De Morgan's. So this is the same thing as saying A or B all complement. So that's like saying 1 minus the probability of A or B. We know the probability of A or B from way up here. So I get 1 minus 0.7, so that gives me 0.3. This, again, I used De Morgan, so I get probability of A and B complement. So that's the same thing as saying 1 minus probability of A and B. Wait a second, is there anything in common between A and B? Absolutely nothing. So the answer is just 1. All right. So then let's move on to this one here. It's got lots of different things. So they want us to find the probability of U and V. Okay, so U and V together. So let's think about it. I think there's going to be an intersection. I think that's what this is saying. So let's just set it up. Probability of U plus the probability of V minus the probability of U and V. Okay, so let's take this guy apart here. So using De Morgan's, let me make some room up here. Using De Morgan's, figure out what that means. Okay, so this is probability of U and V all complemented, right? And they're telling me that that's what 0.4 is, right? So I know that that means 1 minus U and V is equal to 0.4. So from this equation, I can figure out that this quantity is going to be 0.6. So 0.6 for that one. And then let's see what else they give us. This is a 0.6. And then probability of U complement is 0.3. So that means the probability of U will be 0.7. So I add all these together and I get that.